Hi, everyone, and welcome to today's insightful webinar on mastering DevOps and Kubernetes synergy. I'm Sindhura, your host for this session, and we are thrilled to have each one of you join us today and explore how DevOps and Kubernetes can streamline, scale, and secure your software deployments. Before we dive in, let's break the ice. Share a fun fact or unique insight about DevOps or Kubernetes in the chat below. Maybe a creative use case or a key lesson you've learned in your DevOps journey. It's always inspiring to see what our community is up to. Or else you can also tell us about yourself or the place you're from, anything, something interesting you could share in the chat below. So whoever has joined from YouTube, Facebook, or anywhere, you just need to put in where you're from or something interesting about, could be about yourself, DevOps, Kubernetes, anything. Okay. So meanwhile, Ashish and Jaydeep, if you would like to share where you're from, and how do you feel today being a part of this webinar? Jaydeep?
Yeah, so I'm feeling very excited to share the DevOps technologies and the Kubernetes architecture and all the components, interconnections. We are going to explain to towards all the audience. Yeah, feeling very excited. Thank you.
So we have this one Mr. Oscar who says I'm new to DevOps, been in the role for just over a year. Every day something new to learn. So agreed. Learning is a never-ending process and it keeps on. No, every I agree with what he's saying that it's no something new every day. Okay, so now I'll move forward with introducing to our experts. So we have our first speaker, who is Mr. Ashish Pandya, Associate Manager of Service DevOps at Ecosmo. With his extensive experience, Ashish has led numerous DevOps transformations, helping companies achieve efficient and scalable development pipelines. Next up is Jaideep Zala, Team Lead in Service DevOps at Ecosmo. Jaideep brings a wealth of knowledge on Kubernetes and has been instrumental in implementing containerization strategies that drive operational excellence. Both Ashish and Jaideep are here to share their deep expertise on how DevOps and Kubernetes work hand in hand to deliver high quality, resilient software. So, before we just start with what we are going to cover for today's agenda, there's this one thought which I wanted to share. In software development, automation and collaboration are two sides of the same coin. This principle underpins DevOps and Kubernetes alike. And throughout this webinar, we will explore how they can revolutionize your deployment processes. Moving forward, I'll walk you through the agenda of what we are going to cover. So we'll be starting with introduction to DevOps and Kubernetes. Moving forward with, we'll be having Kubernetes architecture and its components. Then we'll be understanding why Kubernetes for DevOps is necessary. Then we'll be diving into real life scenarios of how collaboration between DevOps and Kubernetes is helpful. Then we'll be having some case studies and examples. Lastly, we'll be having the Q&A session. In this entire webinar, we'll be also having a live demo, which will be a real-time live demo, wherein you can have more of your doubts and everything cleared as well. So let's now start with the basics. Over to you, Ashish.
Thank you, Sindhura, for setting the tone for this session. Hello, everyone. Thank you for joining the webinar. I am really excited to dive into this topic with all of you. We will start by exploring the core concept of DevOps and Kubernetes, and then we will dive into the collaboration between both. I understand that most of you are aware that businesses need to deliver application more quickly and reliably in today's fast-paced world. DevOps and Kubernetes are two powerful tools. Those can help to achieve these goals. DevOps brings together development and operation teams. It breaks down the traditional silos between these teams and leading to faster development cycles, fewer errors, and more reliable deployments. DevOps use automation tools to streamline the software development lifecycle, including tasks such as coding, building, testing, or deploying and monitoring, etc. So for all these tasks, we can use GitHub, Bitbucket, Jenkins, SonarQube, Docker, all these tools. And these tools help deliver application more quickly. On other side, Kubernetes is an open source system for automating deployment, scaling, and management of containerized applications. It manages networking, storage, and security for containerized applications. It also provides self-healing capabilities. By combining these two approaches, organization can achieve significant benefit in terms of speed, agility, and scalability. So now let's move forward with the Kubernetes architecture. Here you can see that there are multiple components in Kubernetes cluster. It is distributed system composed of master node or control plane and worker node. Apart from that, Kubernetes cluster have core resources like pod, namespace, deployment services, etc. This design enables resilience, high availability, and scalability. Now let's start with the control plane. The control plane is the brain of the Kubernetes cluster. It manages the worker node and the workload running on them. Its key component includes API server, scheduler, controller manager, HCD, or cloud controller managers. So now let's start with the API server. It is entry point of the cluster. It controls the cluster with help of REST API. We can also use command line interface like kubectl to manage cluster. Another important component is scheduler. The scheduler assigns workload to the nodes. It evaluates each pod's requirement and select the most suitable node based on factors like available resources, affinity rules, taint and tolerations, and other policies. Another key component is controller manager. The controller manager is responsible for the controller that regulates the state of the cluster. It includes node controller or job controller or endpoint controllers. Node controller manages work node and endpoint controller manages endpoint associated with the pod. Apart from that, control plane contains a database known as etcd. This is a consistent and highly available key value store that Kubernetes uses to store all cluster data. Apart from that, or if you want to connect with public cloud with your Kubernetes cluster, then it is also possible with the CCM. So here in this diagram, CCM is a cloud controller manager API. Now let's understand the worker node component. Worker node are where application run. Each node has its own operating system as well as necessary tool to run container as a pods. A typical node includes kubelet, container runtime, and kubeproxy. Kubelet is an agent on each node that listen for command from the control plane. It ensures that containers are running in a pod as directed by the scheduler and maintains the node's health. Container inside pod is created by container runtime. So container runtime is the software like Docker, Containerd, and CRIO. So we can use any of them. Another key component is kubeproxy. Kubeproxy is a network proxy that manages network rule on each node. It forwards requests to the correct pod within or across node and help ensure seamless communication with the pod. Now let's understand key terminology of Kubernetes architecture like pod, namespace, or deployment, or PVC, etc. So let's start with the pod. Pod is smallest unit on Kubernetes cluster. It contains containerized application, and single pod can contain multiple containerized application as well. At cluster, namespace is used to distribute application logically. Your web app can be in namespace 1 and backend can be in another namespace. That way, application is separated in cluster. Deployment is used to manage pod lifecycle like pod creation, pod scaling, and pod healing. Services is used to create network rules for the pod. If you want to attach storage, then there is a service like PV or PVC. There is another service like ingress helps to external connection of the pod. So that's all for Kubernetes architecture and its terminology.
That was an amazing explanation by Ashish. This framework grid allows teams to seamlessly manage applications, life cycles, scale services, and maintain consistent deployments. Now, moving forward, we will understand the key challenges in the software deployment process explained by Jaideep.
Thanks for the great overview, Ashish. So now that we have a solid understanding of the Kubernetes architecture, let's dive deeper into how we can leverage these components to efficiently deploy and manage the applications in a Kubernetes cluster. Now, about one of the primary challenges in the software deployment is managing the underlying infrastructure. For example, resource provisioning, consistency of the configuration, and management of the resources, etc. Apart from that, scaling the application efficiently is a significant concern. Also, the deployment becomes more complex, especially with the multiple environments, dependencies, and the distributed services. Despite robust deployment practices, applications can still fail, often with the unpredictable causes. Addressing failure involves both preventive and reactive approaches. So, next, let's move to the next slide, which will provide a solution for the above challenges and the software deployment process. Okay, so solution for the above challenges lies in the collaboration between DevOps and Kubernetes itself. DevOps and Kubernetes are complementary technologies that, when used together, can streamline the development and deployment of applications. DevOps tools can automate the process of building, testing, and deploying the containerized applications to Kubernetes cluster, while Kubernetes provides a scalable and reliable platform for running these applications. By running these two approaches, organizations can achieve faster deployments, higher agility, and improved application reliability. During this collaboration, we should consider these key factors. So for CI/CD pipelines with Kubernetes, we can use Jenkins and Argo CD can automate the deployments, which will ensure the faster and more reliable delivery cycles. To manage the infrastructure as a code, we can use the Helm and customize to ensure the consistency and scalability. To make sure the configuration management will be effortless across different environments. For monitoring and logging, we can use Prometheus and Grafana to provide the real-time visibility, while the ELK stack will centralize the logs for efficient issue resolution. To improve the security, Kubernetes RBAC, which is the role-based access control and network policies, which will provide the control who can access the system and how the data moves between the services, which is reducing the risk and ensuring everything stays secure and compliant. Now, over to you, Ashish, for walk us through the workflow diagram.
Thanks, Jaydeep, for great explanation of collaboration between DevOps and Kubernetes. Now let's walk through the CI/CD pipeline diagram to see how code moves from a developer's local machine all the way to deployment in a Kubernetes cluster with the monitoring. This pipeline automate and integrate key stages to ensure efficiency, security, and reliability and deployments. Process start with the code development. Here you can see that developer makes a code change in local Git repository. It will be pushed to remote Git repository like GitHub or Bitbucket. Those are the version control systems. As a part of this workflow, Jira will be used to track the issues. Once code is pushed, CI part comes into the picture. Here, Jenkins is integrated with Bitbucket to automate CI/CD. When code is pushed to Bitbucket, it triggers pipeline to automate build process. During pipeline execution, first code quality will be checked at SonarQube. SonarQube analyzes the code for potential bugs, security vulnerability, and code smells, ensuring that only high quality code proceeds through the pipeline. After passing code quality checks, Jenkins trigger Docker to make application as a Docker image. Docker packages the application and its dependency into a containerized image, which can run consistently across different environment like production, UAT, or development environment. Once the Docker image is built, it is scanned for vulnerability using Aqua Trivi tool. Once the Docker image passes security checks at Trivi, it is stored in a Nexus repository. Nexus serves as a central repository for container image and other artifacts. Once image is stored at Nexus repo, continuous deployment will be started. Kubernetes is our platform for orchestrating container, providing scaling, high availability, and load balancing for applications. Argo CD is our continuous deployment tool here. It monitors changes in a Git repository and deploy the updated application to the Kubernetes cluster automatically. Argo CD ensure that the live environment matches the desired state defined in the Git repository like GitHub or Bitbucket. For deploying application on Kubernetes, Helm chart can also be used. Helm is a package manager for Kubernetes that simplifies deployment by managing configuration files. Argo CD can also use Helm chart to configure and deploy application in a repeatable way. Once the application is live in Kubernetes, monitoring becomes essential. Prometheus monitors its performance. It collects metrics related to resource usage, response time, and errors. This data helps us identify performance bottlenecks and troubleshoot the issues. Grafana is connected to Prometheus to visualize the metrics in an easy to understand format. Dashboard in Grafana provide real-time insight into application health, usage trends, and alerts, which helps the team respond proactively to the issues. Throughout this process, there is a notification system that sends update to the team via email or other channels. These notifications keep team members informed about the pipeline status, such as build successes, failures, deployment, and any detected vulnerability or issues. Overall, this setup streamlines the deployment process and helps in maintaining a secure, scalable, and reliable production environment. Now, let's check live demo for this workflow. Okay, so let me showcase you the page which we have developed for this demo. So this page is developed in Node.js. So you can see that current content is hello, this is demo page for webinar. Okay, and this code is stored in this repository, which is GitHub repository. Now I will make a change and that change will be reflected automatically on this page. So let me make the change first. So this is my local machine where I am making the change. So I am changing this content as a version v1. Now I will push this change into the remote repository. Once push is successful, you can see that change on GitHub. So this is my GitHub repository. Here you can see that current content is hello, this is demo page for webinar. Now I will just refresh this page. You can see that the code which I change in my local machine, it is reflected into the remote repository, which is GitHub. Once this code change is updated into the GitHub repository, CI part will be executed by the Jenkins. So let me open Jenkins UI. So we have created a pipeline for Node application, Node.js application. So here you can see that the new build is initiated. If you want to see a whole CI/CD process, then there is a plugin like OpenBlueOcean. You can install that plugin with Jenkins, and in that plugin, you will get UI to see CI/CD process. So here you can see that Jenkins has checked out the source code and it has initiated code analysis at SonarQube side. So this is SonarQube UI. So SonarQube is analyzing Node app application code, and if it found any bug or vulnerability, it will fail this analysis. And if everything is smooth, then it will pass the code. Okay. And this is Docker repository. So in Docker repository, you can see that previous build was created 30 minutes ago and build number was build 49. So new build number will be build 50 for this change. So let me go back to the Jenkins. Here you can see that code analysis at SonarQube is completed. So I am just refreshing this page and will showcase you current analysis. So here you can see that Last analysis was done 1 minute ago, and that analysis was passed successfully. And once analysis passed successfully, Jenkins will start to create Docker images, and that Docker image will be stored into the GitHub repository. So now Docker image is created successfully, and Jenkins is pushing that Docker image into the GitHub repository. So we can see the status over here. I'm just refreshing Docker repository. Yes. So you can see that a few seconds ago, build 50 was created by the pipeline. And once this build is created, Jenkins will start deployment at Argo CD. So this is our Argo CD UI. So in Argo CD UI, we have created one application which is Node application. So this Node application will take version from the Docker repository and it will upgrade the current version. So you can see that current version is version build 49, and when I refresh this page, you can see that current status of the deployment. So I'm just refreshing the Argo CD page. So you can see that it has started node application deployment with the newer version, which is version build 50, and it has terminated previous version, and that version will be terminated in few seconds, and our new version is already deployed. We can see the status into the Kubernetes backend as well. So this is my Kubernetes cluster. So here you can see that new pod is created 27 seconds ago, and previous pod has been terminating state, which was created 62 minutes ago. Now let's see the change which is reflected or not onto the page. So I'm just refreshing this page, and you can see that v1 tag was updated into the page. So that way you can also create your CI/CD pipeline. So this I have just explained the demo, and now we can conclude this demo, live demo.
So, Ashish, that was a really interesting, demo regarding the CI/CD process, and thank you for walking us through. And I hope the people, audience, you have learned something new and how this process can be implemented. So that was now all with the demo part. Now that we would be understanding the benefits of DevOps and Kubernetes synergy. Over to you, Jaideep.
Awesome explanation, Ashish. So the diagram and the live demo provides a comprehensive automated approach to the modern software delivery with automation in place. So each stage of the pipeline from code quality checks to deployment occurs much more rapidly, enabling the faster and more frequent releases. These approaches make it much easier to scale the applications based on the real time demand, ensuring that resources are allocated efficiently without manual intervention. It also provides the flexibility to deploy the application consistently across various environments such as dev, UAT, and production, minimizing the configuration drift and ensuring a smooth deployment process every time. Moreover, it ensures the efficient resource usage and maintains the application performance even under fluctuating workloads, which is crucial for maintaining the service reliability. The synergy between these tools also supports the automated failover and self healing capabilities, ensuring the minimal downtime and a resilient, always available application environment. By improving the code quality, security, scalability, and observability, this setup enables organizations to deliver the application faster, more reliably, and with reduced operational cost. Overall, it fosters a strong DevOps culture that drives rapid innovation while maintaining the high standards for the quality and reliability. So let's dive into some real world case studies to see how these concepts have been applied. Over to you, Ashish.
Thank you, Jaideep. Now let's look at two success story where this architecture was implemented. These examples highlight the benefit and outcome of using workflow, showcasing how it helps solve specific challenges in a software deployment and management process. One of the customer is in VoIP business. They are releasing new release frequently, but deployment process was slow. Apart from that, deployment was not reliable due to unavailability of failover. After adopting this architecture, they achieved faster deployments. This reduced the time required to deploy new feature and because of automation minimize the risk of human error. Deployment time has been significantly reduced because of failover and monitoring. It became more reliable. In this project, Bitbucket, Jenkins, Sonar Cloud, Nexus Repo, or Kubernetes have been used, where Kubernetes version is 1.28, and different services like deployment, pod, PV, PVC has been used. Apart from that, Calico network plugin have been used for this project. For monitoring and logging, Prometheus, Grafana, Alert Manager, Loki, and Promptel have been used. Another customer has web-based application which has multiple microservices and facing issue to deploy microservices efficiently. With the help of this architecture, goal was achieved. Here, Bitbucket, Jenkins, SonarQube, TestTeam, Trivi, Kubernetes, Argo CD have been used for this deployment. Kubernetes version is also 1.28 here. Inside the Kubernetes cluster, multiple application has been deployed with help of the affinity feature. I hope this case study might have helped to understand the synergy between DevOps and Kubernetes.
These examples were indeed very helpful to understand, especially for the VoIP service provider and the telecom company, showcase some really tangible benefits that organizations have realized by integrating DevOps and Kubernetes. I can also see regarding the demo, Ayushi Shah says it was an interesting demo. Then there's a comment from Shalini as well. Very interesting and insightful. Thank you for your comment, wonderful comments, everyone audience. So now, moving towards the last part of our webinar, we would like to cover one interesting slide, which is our EcoSmob's DevOps services. So at EcoSmoke, we offer a full range of DevOps services: strategy, testing, and monitoring, end-to-end implementation, integration, and cloud management, managed DevOps services, and cloud partnering with telecom knowledge. With that, we have different stacks that we are utilizing, which includes AWS, Bitbucket, GitHub, Argo, Jenkins, Docker, Google Cloud, Ansible, Kubernetes, Terraform Cloud, and we have some Sonar Cube, Grafana, Podman, Azure. So these are the some Prometheus. These are the some solution technology stack that ensure that businesses can scale confidently and deploy with ease. So now we are moving for the final session, which is over to you, everyone. If you have any questions or want to discuss some specific queries from the demo as well, feel free to drop them in the Q&A session below. So we'll be answering all the Q&A session. So we have one comment from Manju as well. A very good explanation. Thank you, Manju. So I would request everyone, if you have any queries regarding the demo or anything you would like to understand on the Kubernetes and DevOps synergy, please feel to drop in those questions. We would love to answer them. So we have this one question from Kishan. What are the best practices for containerizing applications for Kubernetes?
Yes, Sindhura, let me explain that question. Let me take up this. There are multiple things which should be keep in mind during deployment and Kubernetes cluster. First of all, image should be lightweight. Image should be scanned with tool like Trivi. Environment variable should be used with help of config map. We should set up liveness probe and readiness probe to monitor application health. We should also set up resource limit for CPU and RAM during application setup inside pod. Monitoring and logging should be enabled with tools like Prometheus, Grafana, and ELK. For application upgrade, we can use rolling update or blue-green deployment in Kubernetes to avoid downtime and facilitate rollback if issue arises. So these are the best practices we should follow during containerized application for the Kubernetes.
So, hi Kishan, I hope your question has been answered. So we have another question from Sankit. He is asking any security perspective suggestions while using Kubernetes.
Yes, so let me take up this question. Hello, Sanket. So whenever we deploying application in Kubernetes, then we should use multiple things for the security perspective. So first of all, we should keep secret at vault. Okay, whenever we are doing CI/CD or we are configuring those secret with the Kubernetes cluster. Apart from that, Docker images should be scanned with the Try. Containerized application should be run with least privileges. We should also use load balancer or ingress controller in cluster so that we can avoid expose of our application. Apart from that, we should use RBAC with inside the Kubernetes cluster to restrict the access. And also logging and monitoring should be enabled in the cluster for the audit purpose as well as the monitoring of the application. So I hope this will clear your doubt.
Thank you, Ashish, for explaining. We have another question as well from Vishal. Hi, Vishal. Thanks for joining. So he's asking, please explain how to set up Argo CD in CI/CD.
Okay, Vishal. So, whenever you are setting up Argo CD in CI/CD, so that Argo CD will be set up inside the Kubernetes cluster only. So, it will have integration with the Git repository as well to monitor the changes. And Argo CD itself contains application which has feature to integration for the CI/CD for continuous deployment.
Okay, thank you. As I was going through the demo, I myself have a question. So, how do you diagnose and debug issues with Kubernetes application?
Okay, so for this, let me answer your question. So, as we know, like we are debugging the issues with the Docker Compose, and we can use the logs. So, with that, we can use the kubectl logs and the name of our deployment or the service. By using the logs facility, we can easily debug like what's going wrong or if every service is inside that deployment is running fine or not. Yeah.
Okay, thank you, Jaideep. So, okay, Mr. Oscar has one question. Are there any other tools like Jenkins that you can suggest or that is the best to use?
So let me take up this question. Yes, Oscar. So there are multiple tools available in market which we can use in replacement of the Jenkins. So if you are using GitHub or GitLab repository or Bitbucket repository, so they are also providing inbuilt tool for the CI/CD. So Bitbucket also have a CI/CD pipeline support, and GitLab has a GitLab operations, or GitHub has a GitHub operations. So with help of those operation, you can set up whole CI/CD pipeline.
Okay, we have one comment from Kishan. Well explained. Thank you. I'm glad we could satisfy your question answer. And so there's this one more question. How do you manage deployments across multiple environments in Kubernetes?
So if you want to manage multiple environment, then you can use namespace feature which I explained during Kubernetes architecture. So with namespace, you can logically separate your environment. So for production, you should have a different namespace. For a development environment, you should have a different namespace. So that way you can separate your environment.
Okay, thank you. There's this one more comment. The session was insightful and engaging, even for the fresher like me in the field. Thank you. Thank you, Jaideep. I am very glad that you found this session very interesting. Varshil Shah has said, well explained. Thank you, Varshil. Any other questions? If you could just put in all your questions, we would like to answer all your questions. Anything in demo? Is there any specific part or anything that you would like to understand? We could explain that as well. How the automation and everything was set up in the entire CI/CD process. Okay, so there's this one more question, which Ayushi is asking: which feature service of Kubernetes helps in scalability?
Okay, so let me help you, IUC, with your question. So we can scale the application by using its manifest file itself. So we can define the scale type if it is in the spec itself. Like in the deployment, we have defined the name, and we can define the minimum replicas or the maximum replicas, and the type we can use the resource with the name of CPU, and we can define the average utilization as well, like when we want to scale up the port from 3 to 10, or the number you would like to scale up your port. So if let's say we are putting the configuration with 70, so whenever the CPU load will hit to the 70, accordingly the replica will be also increased. I hope this answer your question.
So we have one more question from Shalini. She wants to understand what is the difference between a replica set and a deployment in Kubernetes.
So in Kubernetes, replica set is a part of deployment. So whenever we are deploying pod, so that pod can be deployed with the manifest file of the deployment, and inside that deployment manifest file, there is a definition of the replica set. So let's say you want to create one or more replica with your of your pod, then you can use replica set inside the deployment file. Apart from that, if you want to increase your replica by command line, then also you can use replica set to replicate your application inside the pod.
Okay, thank you, Ashish. Oscar is also asking what is the recommended learning resources for those new to DevOps. Is the recommend path to follow?
Okay. So for this, yeah, let me help you, Oscar, with this. So I will suggest like we could use the Linux, basics of Linux, the version controlling thing, scripting part, the networking, and the security one also necessary. We can explore the CI/CD tools like Jenkins, GitLab CI, or GitHub Actions. Yeah, configuration management is also necessary like Ansible or Ceph. For container, we can dive more into the Docker. And yeah, obviously, for monitoring and login, we can use the Prometheus and Grafana. So I hope that answers your question.
Okay, we have one more question. Explain the concept of stateful sets and how they differ from deployments in Kubernetes.
So stateful set is basically used to manage whenever your application need to manage the state of that application, and that case only we are using stateful set. If your application is stateless, then we can use deployment. So that way you can identify whether your application needs statelessness or statefulness, and based on that you can define you want to deploy stateful set or a deployment.
Okay. And there's this one more. How does Kubernetes handle service discovery and load balancing for pods?
So Kubernetes also have a inbuilt feature like ingress or services. So whenever you create a services, then in that service it also support node port, load balancer or cluster IP. So if you have created your services as a load balancer, then it will manage load balancing of your pod with help of that services. Apart from that, ingress can also use to load balance the traffic across the pod, which is configured as a backend behind the ingress controller.
Okay. There's this one question from Mudrika. She's asking, can we integrate Kubernetes logs to ELK?
Yeah. So for this, instead of ELK, I will suggest to go with the Fluentd, which will collect all the logs from the Kubernetes cluster, and we can easily integrate with the Elasticsearch and represent and diagnose any issues or any analysis you want to do with from the Kubernetes logs or from the services as well. That will be the most preferable approach to use EFK.
Okay.
Yeah.
Then there was one more question from Sanket. He's asking which cluster will be ideal, a self-managed or managed by any cloud provider like AWS, Azure, etc.
So it is totally depend on the customer requirement. And if you are using your self-managed cluster, then or if you want to use any cloud provider like AWS Azure cluster, like EKS, okay. So there will be a cost comes into the picture. So you want to decide whether you can afford that cost or not. And based on that, you can identify your requirement and you can deploy self-managed cluster or you can use any public cloud provider cluster.
Okay. Mudrika says thanks for the suggesting. Thank you, Mudrika, for your comment. Then we have this one more question. What is Kubernetes namespace and how does it help in managing resources?
Okay, so with by using the namespace, we can completely isolate the different ports or the services which we don't want to communicate with each other. So if you have created one deployment in one namespace like Gate1 and deployed another service in the different namespace, then you have to do the proper communication between two services until and unless if it is not required. So yeah, by that way, we can use the namespace as and when needed as per the project requirement.
Okay, thank you. Then, what is this immutable infrastructure and how could you apply it within a DevOps workflow?
Yeah. So for immutable, I think like we have seen, like if you have created a deployment and a port is running in that particular isolated environment, then somehow that application got crashed. So it's Kubernetes will take care of everything due to any reason. If that particular port will be terminated or deleted by someone accidentally, so at the next fraction of second, then the same service will be started by Kubernetes itself. No any manual intervention is needed. So yeah, by that way we can create the immutable environment as per our requirement. I hope that answer your question.
Yeah, it did. And there's this one question from Kishore. What are your thoughts on managing the applications having a range of UDP ports published in the Kubernetes cluster?
Okay, so with that, yeah, I suggest to go with the Calico networking. So we can create the networking as as per our requirement and connect all the services with the IP which we have configured in our manifest file and manage the services accordingly. So yeah, if actually the question is very good, and I believe this webinar is not enough to give the proper explanation, but yeah, we can arrange a separate workshop to uh, understand the Kubernetes integration with the UDP port ranges and the integration with the different web services.
Okay, thank you, uh, Jaideep. And there's this one question of asking describe how Kubernetes manage updates with rolling updates and how can we handle zero downtime deployments.
Okay, so whenever we we want zero downtime during upgrade, then there is a rolling update feature as well as blue green deployment feature. So in my demonstration you can see that our pod is created, a new pod is created with new version, and then only current pod was terminated, and that way we have avoided downtime. So with help of rolling update as well as the blue green deployment, you can avoid your downtime.
Okay, got it. And can you share some strategies how to manage and monitor resource utilization in Kubernetes cluster?
So, whenever you want to monitor resource utilization for Kubernetes cluster, then you can use Prometheus and Grafana with Node Exporter. So, Node Exporter will collect resource utilization from your worker node as well as the control plane, and it will store that data into the Prometheus. So, basically, Prometheus fetches resource utilization with help of the Node Exporter, and it is stored in Prometheus database. And with help of Grafana, you can create dashboard and represent that resource utilization. And if you want to send some alert, then also it is possible with the alert manager.
Okay. And if we want to manage an environment specific configurations and secrets in a multi environment DevOps setup, how can that be done?
Okay, so for that we can use the different tools like the Corp Vault and other alternative solutions. By using, we can store the secrets and easily use them as and when needed. And if we are discussing about Jenkins, so in Jenkins we can also store the secrets, passwords, and any API related parameters, which will very secure to use and do not create any vulnerability in your existing system. Yeah.
Okay. So Kubernetes usually integrates with the CI/CD pipelines, and the what could be the benefits of using the tools like Argo CD or Flux?
So Argo CD is basically a GitOps tool. So whenever there is a change in your version or in your application, then that Argo CD will monitor that change and it will deploy that change into the Kubernetes cluster. So let's say you are running your application with version 1, and now you have made some changes into your application, and that version is updated into the GitHub repository. Argo CD will monitor those changes and deploy version 2 into the Kubernetes cluster without any manual intervention. So that way Argo CD is useful in CI/CD integration.
Okay. Then I am a fresher to DevOps, which will be easy to use and set up Grafana Prometheus for monitoring.
Okay, so let me answer your question. If you are fresher with the DevOps, so I will prefer to first gather some understanding of the Linux, and yeah, good to go with the Docker and the Docker Compose file to set up the Grafana Prometheus environment, and go ahead with the default templates available for the Grafana dashboard, by using which you can first check the status of your on node itself, Linux node. Yeah, this will be actually good initiative from your end, and I believe this answer your question.
So, how can we manage and monitor CI/CD pipeline and failures?
Okay. So with CI/CD pipeline failures, we can configure and integrate the different chat platforms like Google Chat. We can integrate the email as well. So whenever, due to any reason, if the CI/CD pipeline will be break in between, we will receive the notification by using email or on the chat space as well. We can integrate Slack channels as well. So yeah, we can integrate the different notification platform with the existing CI/CD pipeline if it is fails or it passed successfully.
Okay. And is this artifact repositories and why they are so important in this DevOps workflow? Artifact repositories.
Okay, so for that artifact repositories, it's really mandatory. Like if you want to store your images, which is being prepared by using your own logic, so definitely we can use the options we have available in the market like Nexus, JFrog, Docker Registry, or the Docker Hub. So based on the requirement, we can store our artifact. If it is a Docker image, if it is actual, the Debian package is whatever artifact it is. But yeah, it's up to us, like where we want to store the artifact. Accordingly, we can see if that feature is available. Definitely, we can go ahead and use the artifact store platform.
Okay. And if there is any debug and troubleshoot failed in Kubernetes pods, how can we manage them? Like how do we debug and troubleshoot failed Kubernetes pods?
So there are command line tools are also available. So whenever your pods is failed, then you can troubleshoot your issue with command line. So there is a utility like kubectl describe. So that way you can describe your pod, or you can see kubectl logs with your port name, and based on that you will get information that why your pod is failing, and you can troubleshoot the issue and you can resolve that issue, and your pod will be up again.
Okay. And what is this exactly this cube scheduler and how does it make this scheduling decisions for the pods?
Okay. So scheduler is basically a important component into the Kubernetes cluster. Okay. So let's say in pod manifest file, if you have defined some resource policy, like in worker node, this much of CPU, like 4 CPU or 16 GB RAM is required for this pod. So scheduler will check all worker node, and whatever worker node is available with 4 CPU and 16 GB RAM, then only it will define or it will create a pod on that particular worker node. Apart from that, there is a important concept like affinity policy. So let's say you want to deploy your pod in auto scaling manner. So let's say your pod 1 should be deployed in worker node 1 and your pod 2 should be deployed on worker node 2 to avoid failover. Okay. So in that case, scheduler will decide that on which node pod 1 will be deployed and on which another node pod to be deployed. So that way scheduler is very important to deploy your pod in Kubernetes cluster.
Okay. That was really interesting Q&A session. Both from no, we had got so many questions and you answered so many things from Jaideep and Ashish. So with this, we would be now concluding the webinar. So I would thank everyone for joining us today. Let's hear some closing statements from Ashish.
Thank you, Sindhura. Thank you all for joining us today. We have covered the fundamental of DevOps as well as orchestration capability of Kubernetes. I hope you found valuable insight to streamline and enhance your workflows. If you have any more questions, feel free to reach out to us. Thank you again.
Jaideep.
Yeah, so thank you all for attending this webinar. Throughout this session, so we have highlighted key aspects of the DevOps and the orchestration potential of the Kubernetes. So I trust these insights will help you to simplify the task and enhance the scalability within your teams. So feel free to reach out if you have any questions. Thank you.
And we would like to thank. We hope this session has provided you with actionable insights into leveraging DevOps and Kubernetes for optimal results. For more resources or to explore Ecosmop's DevOps offering, don't hesitate to reach out on www.ecosmop.com or send us an email to sales@ecosmop.com. We look forward to seeing you in our next webinar. Thank you. Thank you so much. Sri Mulu has said thank you so much for the nice session. Thank you for joining us, and thank you all to the wonderful audience who have joined.